Hello everyone, in this video I'm going to explain you about sort colors. So basically given an array nums, as you can see here nums of n objects. Okay, num size is n, colored red, white or blue, sort them in place so that object of the same color are adjacent with the colors in the order red, white and blue. So they have given array uh, which has colors red, white and blue. I mean three colors are there, and we need to put them all colors adjacent in such a way that first uh, group of reds has to be there, second group of white and third group of blues. We will use the integers 0, 1 and 2 to represent the color red, white and blue respectively. So red is represented with 1, white with 2, white with 1 and blue with 2. So you must solve the problem without using library sort function. Okay, what they're saying don't use library sort function. We'll use library sort function only first time. I'll be using three methods. So first method I'll be showing by using library function only. Nums dot begin comma nums dot end. Just use library sort function and yeah, we don't need to return anything. Just run this code and just submit the code. So as you can see it got accepted, but in question what they have said is don't use library sort function. So let us not use library sort function. We'll use some other thing. We'll use some technique. We'll use it. So as you can see in the array nums we have 2 which is basically blue color, 0 which is basically red color and 1 which is basically white color. So we'll have to put it this way 0 0 1 1 2 2. So basically think of this way, like we have array of zeros, ones and twos. We need to sort array such that zeros will be first, second time will get 1 and third element should be twos. So as you can see here 0 and 2. So yeah, so and they have said don't use any extra array. So in place is basically in this array only you'll have to do it. So one technique is we'll iterate through this array and we'll keep 3 variables which keeps count of zeros, ones and twos. And once we get these counts, so first time we'll insert zeros and second time we'll insert ones, third time we'll insert twos. So let me do this. Count 0 equals to 0, count 1 equals to 0, count 2 equals to 0. So we'll iterate through this nums vector, and what we'll do is if num equals to 0, which means count of 0 plus plus, else if num equals to 1, if it is 1, so count of 1 plus plus will do it. Else it is obvious that apart from 1 and 0 there has to be 2 only, so else we'll do it count 2 plus plus. So we got count of these 1, 2s and zeros in the nums array. We need to sort, like zeros has to go first, 1 has to go second and 2 has to go third time. So what we'll do is we'll initialize one variable I is equal to 0 while count of 0. Okay, and we'll put it this way. Okay, while count of 0, if there is at least one element also, we'll have to put that in nums array. So we'll put it here nums of I equals to 0, and once we put 0 we'll decrease the count of 0 by 1 and we'll increase the index. In the same way we'll have to do it for count of 1 as well. Nums of I equals to 1 in this case, and count of 1 minus minus and I plus plus. Let me do it for second also. Count of 2, nums of I equals to 2, count of 2 minus minus I plus plus, and this will work accordingly. Let me try to run the code. It is running fine. Now let me submit the code. Yeah, this also is got 100% accepted, I mean good. uh, but if you analyze the time complexity of this, so as you can see, this is running for n times, and these loops combined will be running for n times, so it's basically time complexity is 2n, and space complexity is 1. We don't use any vector or something like that. So can we also improve, try to improve this algorithm? See, we are solving this in 2n. Can we solve it using n, O of n, in one iteration only? We can do that. So let me try to do that way. So what I'll do is I'll keep 3 variables, okay, initialize it to, let me take one notepad, one note. So yeah, so we have here 2 0 2 0 2 1 1 0. This is first example. We'll keep 3 variables, I, j and k. I basically will be traversing through this array from left to right, and j is the point or position where 1 will start. 1 will start basically in the sense, I'll tell you, okay. And k is the position that will keep count of, I mean keep track of 2's from right to left, okay, and j will keep from left to right. So initially what we'll do is we'll initialize I to 0, j to 0, and k to n minus 1, okay. So our k will be here, I will be here, and j will be here, and we will iterate, I mean while I is less than n, we'll iterate through the loop, and if you find that if I of if I is 0, so we will replace with the jth, we'll swap with the jth, and we'll increase I plus plus. So basically what I'm trying to say, I'll tell you. See, let's say we have here ones, and here we have zeros. Sorry, not this one, let me take one more. We have zeros, this many, we have 1, and we have 0 here, and here 1 2 1 0, something like that, here 2 2 2. So our I pointer will be here, let's say we have here, and j is here, and k will be here at this position, okay. So now we are checking this one. If I is 0, so ideally this 0 has to come here, okay. We are trying to make 3 segments. First is 0, the second segment has 1s, the third segment has 2s, and in between whatever we have it, we will trying to put in one of the segments, okay. So if it is 0, what we are trying to do is we will try to swap with the jth one, okay. If we swap here, so what it will come is this will be replaced, okay. So it will be 0 0 0, and here we have 0, and this is 1 1, these two ones, and here we have 1, and I is pointing still here, and j is pointing still here. As you can see from this segment, 0 is sorted, 0 came here, and 1 it I mean yeah, it is sorted, and 1s is also not reflected anything. So and second next element is 1 2 1 0 2 2 2, and our k is here. So since we know that this is sorted now, this is also sorted, so I mean till here, and we'll have to increase I by 1 and j by 1, okay. So j is basically keeping track of start from where the 1 starts, and I is basically the unsorted segments, keep track of unsorted segments, and k keeps track of k will be here actually. K keeps track of end unsorted segment. Okay, so now let's say we have I here. If it is 1, then we'll simply increase I by 1. Okay, now if it is 2, so 2 means this has to go to this segment. Okay, so what we'll do is we'll swap these value with the k value. I and k will be swapped. So now as you can see, these 0 4 zeros we have here. This is one segment, and we have 4 4s now, and our j is at this point, and 2 is replaced with the 0. So we have 0 here, we have 1, we have 2, and these 3 2s we have already, and k it was here. Now we'll decrease the k by 1, which means this is the unsorted segment now, and I in this case will not increase as, because this was unsorted, we swapped with the unsorted only, and these two got sorted, but still 0 has to be sorted properly, so we are putting it I, we are not increasing I. And in the next iteration, if you see 0, then again we'll swap with this element. Okay, yeah, we'll swap in this element, and it will be 0 0 0 0, and this 0 comes here, and it will be 1 1 1, and this one will go at this place, and we have other one and 4 2s. Okay, and as you can see here, j it was here actually, now j will be increased by 1, and I, if you see, it was here, but I will be increased to here, and k is also at this place, and we need to do till I is less than k, less than equals to k. So I think you got what I am trying to do, segments. Let me try to code up. So we'll take 3 variables I, j and k equals to nums dot size minus 1 while I is less than equals to k. First time what we'll do is, if nums of I, if it is equals to 0, we will swap with nums of I and nums of j. Okay, and we will try increase j by 1 and I by 1. Else if nums of I, if it is equals to 1, which means it is already sorted, it is in correct position, we just increase, we need to just increase I. Else in the sense nums of I is 2, so in that case we were swapping with nums of I with nums of k, and we were decreasing k by 1, and I was constant, we were not doing anything, because k holds of, keeps track of unsorted element only, and I also keeps track of unsorted element. But in this case, 0 and 1 case, j keeps track of starting sorted of 1, so we need to increase by 1. So yeah, this is good. Now we'll try to run the code. Now let's submit the code. As you can see, this also got accepted. So this algorithm has time complexity of over 1, and this is the most optimal solution you can have. So thank you guys for watching my video.